Alright, so in Huntington disease, you find that usually this is because there's a fault with the indirect pathway. So you will notice that due to changes in the indirect pathway, we have in the striatum itself, the GABA releasing neurons degenerate. Okay, so let's see if I can go back to that. Okay. So I'm just redrawing what it's like. This time I've used black for the excitation ones and blue for the ones that are inhibitory. So you see that the neurons of the striatum, so it's here where you have a problem. Okay, so the neurons of the striatum seem to degenerate, and this leads to a reduction in the inhibition of the thalamus. So if this is reduced, you'll find that there's release of more GABA. Okay. All right. Just let me go step by step. I think I'm rushing through this. Okay. So you find that the striatopalidos do not release as much GABA. Okay, so the GABA here is reduced. So because GABA is reduced, there's not much inhibition going on here. So in the subthalamus, you find an increase in GABA. So if you're going to find an increase in GABA here, it means you are literally inhibiting the glutamate in the GPI. So if you are inhibiting the glutamate, you are not releasing as much GABA in the thalamus. So if you're not releasing as much GABA in the thalamus, what is going to happen? It means you're not inhibiting the thalamocorticals as much. So if you're not inhibiting the thalamocorticals, it means there will be more unwanted movement. And in this case, it won't just be the facilitatory, but as much as unwanted movement as possible, because the striatum is has got degeneration happening. And so you'll find that in these individuals, the early signs would just be jerky trajectory of the hand when reaching a spot, and hyperkinesia, chorea, incapacitation as well, slurred speech, and dementia. And you also note that this is inherited as an autosomal dominant disorder. So that is Huntington. I'd also like to say something about Wilson's disease. So in Wilson's disease, this is a very rare for Wilson. This is a very rare autosomal as well, autosomal recessive disorder, and it's usually a disorder of copper metabolism. So when there's an issue with this, it affects the copper transporting system. Okay, specifically the ATPase gene in the liver. Okay, and this leads to accumulation of copper. So copper will accumulate in the liver, and this will result in liver damage. You also have it around the periphery of the cornea in the eye. So you have a very characteristic yellow achalasia ring. The dominant neurological pathology is degeneration of the putamen, and also part of the lenticular nucleus. All right. The other ones are tardive dyskinesia, which is due to medical treatment sometimes. But before I close, I think the main thing that I would like to put out is what is the difference between the basal ganglia and the cerebellum. Okay? So the basal ganglia receives from most areas. So receives from most areas, specifically of the cerebral cortex. Whilst the cerebellum receives from restricted parts. So this is restricted. In terms of output, we see that in the basal ganglia it's widespread. It actually reaches the prefrontal as well as premotor, whilst in the cerebellum the influence is only on the premotor and the motor cortex. Basal ganglia, they do not receive somatosensory. Okay, so they don't receive whilst there's somatosensation here. Maybe one more thing is that the basal ganglia function is really for movement and dampening unwanted movement, whilst the cerebellum is mostly for modulation, correcting of errors, and smoothing. Alright, so that's where we're going to end. Please be on the lookout for the next piece.